In this video, we're going to talk about how to determine the sales price after a discount is applied. So let's start with this problem. The price of a laptop is $400. How much will it cost if a 15% discount is applied, excluding any sales tax? Well, the first thing we need to do is find out how much 15% of 400 is. So what is 15% of 400? Well, let's see if we can do this mentally. First, let's determine 10% of 400. To find 10% of anything, just move the decimal 1 unit to the left. So 10% of 400 is 40. Now, if 10% of $400 is $40, what's 5%? Well, 5% is half of 10%. So if 10% corresponds to 40, 5% corresponds to half of that. Now, to determine 15% mentally of 400, we simply need to add 10% and 5%, because 10 plus 5 is 15. So thus, if we add 40 and 20, we get 15% of 400, which is $60. So that's 15% of 400. Now, if you wish to use a calculator to get the exact answer, multiply $400 by 15% as a decimal. To convert a percent to a decimal, divide by 100. If you take 15 divided by 100, you get 0.15. 400 times 0.15 is $60. So those are two ways in which you could determine the percent of a number. So now let's calculate how much it will cost after a 15% discount. So the original price is $400. 15% of 400, we know it's 60. So we're going to discount the price by 15% or $60. The difference between 400 and 60 is $340. So this is the new price of the of the laptop rather, after a 15% discount is applied. Now this is another way in which we can get this answer, and we could use this formula to get it. So the new price, this is the price after the discount, is equal to 1 plus or minus R times the original price. Now, because we're dealing with a discount, that's going to decrease the value of the laptop. So we're going to use negative R as opposed to positive R. If we were dealing with sales tax, that will increase the total price paid. So for sales tax, you would use positive R. So it's going to be 1 minus R. R is 15%, but as a decimal. So that's 0.15 times the original price, which is 400. 1 minus 0.15 is 0.85. So if we multiply 0.85 by 400, this will give us the same final answer, which is 340%. Now I want you to think about this mentally. This is 100% of the original price of the laptop. If we have a 15% discount, that means that we're going to pay 85% of the original price of the laptop. And that's what we're doing here. If we calculate 85% of 400, we can go directly to the final answer, which is 340. Now let's move on to number 2. Rachel wants to buy a car for $25,000. What will be the new price of the car if she receives a 6% discount? Well, first, let's do it mentally. What is 6% of 25,000? Well, we know that 10% is 2,500. You simply need to move the decimal 1 unit to the left. If 10% is 2,500, what's 1%? 1%, you need to move the decimal 2 units to the left. 1% of 25,000 is $250. So now if you know what the value of 1% is, you can easily find the value of 6%. 6% is 6 times 1%, or it's going to be 6 times 250. If you had 6 quarters, you would have $1.50. So 6 times 250 is $1,500. So that's 6% of 25,000. So if we discount the original price by 6% or by $1,500, we're going to get the new price. And so the new sell price will be $23,500. Now let's confirm this answer using the formula that we had earlier. So the new price is going to be 1 plus or minus R times the original price. So we're dealing with a discount, so it's going to be negative R. 6% as a decimal is 0.06, and the original price of the vehicle is $25,000. So if we're discounted, if we're decreasing 100 by 6%, we're going to have 94%. So the new price is going to be 94% of the original price. 0.94 times 25,000 will give us the same answer, 23,500. So now you know how to calculate the sales price of an item after a discount is applied. In this video, we're going to focus on calculating percent error. So here's a problem. Let's say that you have an experiment and you're measuring the density of aluminum. And let's say your measured value is 2.6 grams per cubic centimeter. So this is how much you got in the experiment. Now the accepted value, or the actual density of aluminum, this is what you want to get in your experiment. This is the ideal value, is 2.7 grams per cubic centimeter. So based on this, what is the percent error in this experiment? So here's the formula. So the percent error is equal to the absolute value difference of the measured value, or your experimental value, minus the actual value divided by the actual value times 100%. So the percent error is going to be the difference between these two numbers. So we have a measured value of 2.6 and the actual is 2.7 divided by 2.7 times 100%. So 2.6 minus 2.7, that's equal to negative 0.1. And the absolute value of negative 0.1 is positive 0.1. So positive 0.1 divided by 2.7 times 100%. Let me get out my calculator. Let's plug this in. And so I got 3.7%. And so this is the percent error for this experiment. Now, if you need to calculate simply the error, not the percent error, but just the error, here's what you can do. The error is the difference between the measured value and the actual value. So in our example, the measured value was 2.6 grams per cubic centimeter. The actual value was 2.7. So the error is negative 0.1 because we got a value that is just under the actual value. And so that's how you can calculate the error. So now let's try another problem. So let's say our measured value is 7.7 grams per cubic centimeter, and this is for the density of iron metal. We're trying to experimentally measure the density of iron metal. And to measure the density of something, density is basically mass over volume. Now the actual density of iron metal is 7.86 grams per cubic centimeter. So based on this information, go ahead and calculate the error and the percent error. Feel free to pause the video. So let's start with the error. The error is going to equal the measured value minus the actual value. So the measured value we saw was 7.7 and the actual value is 7.86. So 7.7 minus 7.86, so the error is negative 0.16. So now to calculate the percent error, this is equal to the error divided by the actual value times 100%. But this is the absolute value of the error. So remember, the error, you can replace it with the measured value minus the actual value. And if you do, it will give you the first formula that we wrote earlier in this video. So if I take this and substitute it for error, I'm going to get the other version of this formula. And that is the measured value minus the actual value with an absolute value symbol divided by the actual value times 100%. So let's go ahead and finish it. So I'm going to use the second formula on the bottom. That is this one. So percent error is going to equal the error, which is negative 0.16, but we need to take the absolute value of that and then divide it by the actual value, which is 7.86 times 100%. So the absolute value of negative 0.16, that's going to be positive 0.16. So in the calculator, type this in, 0.16 divided by 7.86 times 100%. And so for the percent error, I got this answer, 2.036%. Hopefully you got the same thing too. So that is the percent error for this experiment. So hopefully this video gave you a good idea of how to calculate percent error. In this video, we're going to focus on percentage, base, and rate problems. Like this one. What is 35% of 200? How can we find the answer to that question? Well, it turns out that there is a formula that we could use. And here it is. The percentage is equal to the base times the rate. Now you need to know what is the percentage, what is the base, and what is the rate in this problem. So the base is the number that is associated with the word of. The rate is the decimal form of the percentage, and the percentage is the number that is associated with the word is. So looking at this problem, what's P, what's B, and what's R? So we can see that 200 is associated with the word of. So 200 is the base. 35%, that's going to be the rate because there's a percentage in front of it. And what we're looking for, we're looking for the percentage in this problem. So what is 35% of 200? So now let's use this formula to get the answer. So we want to calculate P in this problem. The base is 200 and the percentage is 35%. That's the rate. Let me not confuse that with P and R. R is 35%. So what is 35% as a decimal? 35% as a decimal is 0.35. So all we need to do is multiply 200 by 0.35 and you'll get 70. By the way, to convert a percentage into a decimal, simply move the decimal point 2 units to the left, or you could take 35 and divide it by 100. Both ways will give you 0.35. But for this problem, 70 is the answer. So 70 is 35% of 200. Now, for the sake of practice, let's go ahead and try another example. 40% is 30 of what number? Feel free to pause the video and try this example problem. So let's use the formula again. Percentage is equal to the base times the rate. So let's identify what we have. 40%, even though it has the percentage symbol in front of it, that is the rate. Now what about 30? Is 30, what does that tell us? The number that is associated with the word is the percentage. So that's P. And then of what number, that's what we're looking for. So in this problem, we're looking for the base, B. So that's what we need to calculate in the equation. Now let's plug in what we know. P is 30. We don't know the value of the base. And we know R, the rate, is 40%. So 40 divided by 100 is 0.40. So now we need to do a little math here. How can we calculate B, the base? In order to get B by itself on the right side of the equation, we need to divide both sides by 0.40. 0.40 divided by itself is 1, so those two numbers will cancel. On the left, we have 30 divided by 0.40, and that will give us 75. And so that is the base, that is the answer that we're looking for. So we can say that 40% is 30 of 75. So that's how we can complete the sentence. Now let's move on to our next example. 45 is what percent of 70? Go ahead and work on that example. So let's use the same formula. P is equal to B times R. So what's P, what's B, and what's R in this problem? So P is associated with the word is. 45 is, so 45 is going to be P. Of is associated with the base. So 70 is the base. The percentage in this formula is associated with R, the rate. So in this example, we want to calculate the value of R. So P is 45, B is 70, and now we need to get R by itself. To do that, let's divide both sides by 70. So R is going to be 45 divided by 70, and we're going to get a decimal. So you should get 0.6428571. And we're going to round it. We're going to say this is approximately 0.643. Now that's as a decimal. We need to convert that into a percentage. To do that, you can multiply 0.643 by 100 or move the decimal 2 units to the right. So R is approximately 64.3%. So we could say that 45 is approximately 64.3% of 70. So that is our answer. So that's it for this video. So now you know how to solve these percentage base rate problems. In this video, we're going to talk about how to calculate the original price of an item after a discount is received. Now, this discount is typically given in the form of a percentage. So let's work on this problem. John paid $320 for a laptop after receiving a 20% discount. What was the original price of the item, assuming that no sales tax was added? So how can we figure this out? Well, there's a formula that can help you to get the answer quickly. So let me write it out real quick. The new price is equal to 1 plus or minus R times the original price. The new price, or the final price, is basically the final amount that John paid for the laptop after the discount. So that's going to be $320. R, you can think of R as the interest rate or the discount. R is the percentage. So because we're dealing with a 20% discount, should we use the positive sign or the negative sign? Well, the discount is going to reduce the price, so we're going to use a negative sign. the new price is going to be less than the original price. So that's why we need to use negative R instead. If the percentage were to increase the price, like a sales tax, we would use positive R. So since we're dealing with a discount, it's going to be 1 minus R. Now what is R? R is 20%. But you don't want to plug it in as a percentage. You want to plug it in as a decimal. So you need to know how to convert a percent into a decimal. Well, there's two things you can do. You could divide 20% by 100, and that will give you 0.20. Or you could simply move the decimal 2 units to the left, which will still give you 0.20. So that's our R value. The original price, we don't know what it is, so we're going to call it X. So 1 minus 0.20 is 0.80. So what this means is that after receiving a 20% discount, the new price is 80% of the original price. Now, in order to calculate the original price, we need to divide both sides by 0.80. So the answer is going to be 320 divided by 0.80. Thus, the original price of the laptop was $400. After he received a 20% discount, it went down to 320. And you could check your answer. You could find out, hey, what is 20% of 400? 10% of 400 is $40. You just need to move the decimal 1 unit to the left. So 20% of 400 is twice the value of 10%, which is 40. Twice the value of 40 is 80. So that's 20% of 400. So if you take off $80, this will give you the new price of the laptop after the discount, which is $320. And so that's a quick way that we could use to check our work. But the final answer for this problem, the original price, is $400. Now let's work on a similar problem for the sake of practice. Lauren bought a car for $12,450. If she received a 17% discount, what was the original price of the vehicle? Well, let's use the same formula. The new price is equal to 1 plus or minus R times the original price. So the new price after the discount was applied is $12,450. So since we're dealing with a discount, we're going to use a negative sign. Now 17% as a decimal. If we divide 17 by 100, that's going to be 0.17. And the original price is what we're looking for. So we're going to call this X. 1 minus 0.17 is 0.83. So if you take off 17% from 100%, then that means that the new price is 83% of the original price. But now to get the answer, we're going to divide both sides by 0.83. $12,450 divided by 0.83, that's equal to $15,000. So this is the original price of the vehicle before the discount was applied. So now you know how to calculate it using this formula. So keep this in mind. The new price is equal to 1 plus or minus R times the original price. In this video, we're going to talk about how to calculate the original price of an item after a discount is received. Now, this discount is typically given in the form of a percentage. So let's work on this problem. John paid $320 for a laptop after receiving a 20% discount. What was the original price of the item, assuming that no sales tax was added? So how can we figure this out? Well, there's a formula that can help you to get the answer quickly. So let me write it out real quick. The new price is equal to 1 plus or minus R times the original price. The new price, or the final price, is basically the final amount that John paid for the laptop after the discount. So that's going to be $320. R, you can think of R as the interest rate or the discount. R is the percentage. So because we're dealing with a 20% discount, should we use the positive sign or the negative sign? Well, the discount is going to reduce the price, so we're going to use a negative sign. The new price is going to be less than the original price, so that's why we need to use negative R instead. If the percentage were to increase the price, like a sales tax, we would use positive R. So since we're dealing with a discount, it's going to be 1 minus R. Now what is R? R is 20. But you don't want to plug it in as a percentage. You want to plug it in as a decimal. So you need to know how to convert a percent into a decimal. Well, there's two things you can do. You could divide 20% by 100, and that will give you 0.20. Or you could simply move the decimal 2 units to the left, which will still give you 0.20. So that's our R value. The original price, we don't know what it is, so we're going to call it X. So 1 minus 0.20 is 0.80. So what this means is that after receiving a 20% discount, the new price is 80% of the original price. Now, in order to calculate the original price, we need to divide both sides by 0.80. So the answer is going to be 320 divided by 0.80. Thus, the original price of the laptop was $400. After he received a 20% discount, it went down to $320. And you could check your answer. You could find out, hey, what is 20% of 400? 10% of 400 is $40. You just need to move the decimal 1 unit to the left. So 20% of 400 is twice the value of 10%, which is 40. Twice the value of 40 is 80. So that's 20% of 400. So if you take off $80, this will give you the new price of the laptop after the discount, which is $320. And so that's a quick way that we could use to check our work. But the final answer for this problem, the original price, is $400. Now let's work on a similar problem for the sake of practice. Lauren bought a car for $12,450. If she received a 17% discount, what was the original price of the vehicle? Well, let's use the same formula. The new price is equal to 1 plus or minus R times the original price. So the new price after the discount was applied is $12,450. So since we're dealing with a discount, we're going to use a negative sign. Now 17% as a decimal. If we divide 17 by 100, that's going to be 0.17. And the original price is what we're looking for. So we're going to call this X. 1 minus 0.17 is 0.83. So if you take off 17% from 100%, then that means that the new price is 83% of the original price. But now to get the answer, we're going to divide both sides by 0.83. $12,450 divided by 0.83, that's equal to $15,000. So this is the original price of the vehicle before the discount was applied. So now you know how to calculate it using this formula. So keep this in mind. The new price is equal to 1 plus or minus R times the original price. Now let's talk about how to solve word problems with percentages. So here's the first problem. John buys a laptop for $299. What is the total price that he pays if 6% sales tax is added? Now, one way to do this is to find out how much 6% of $299 is. So we need to convert the percent into a decimal. To convert 6% to a decimal, simply divide the number by 100. So it's basically 6 over 100, which is 0.06. $2.99 times 0.06 is $17.94. So that's 6% of $2.99. So this is the tax that he pays plus the price of the laptop, which is $2.99. So the total price is the sum of those two values. The total price that he pays is $316.94. So this is the answer. Now it turns out that there is an easier way to get the same answer. At least it's easier in my opinion. And let me give you the formula, because this formula will help you to solve more complex problems, as you'll see shortly in this video. The new price is equal to the original price multiplied by 1 times 1 plus or minus R. Now R would be the percentage. When dealing with sales tax, R is positive because you're going to pay more than the original price. But when dealing with discounts, R is going to have, you're going to use the minus symbol instead of the plus symbol, because the new price will be less than the original price if you have a % discount. So in this example, the new price would represent the total price that he's going to pay for. The original price represents the price of the laptop. That's $2.99. And we're going to use the plus symbol since we're dealing with a sales tax. That's going to increase the total price. And R is going to be the decimal form of the percentage. 6% is basically 0.06. So all we need to do is multiply $2.99 by 1.06. Now, just for you to understand why this works, $2.99 times 1 gives you the original price. $2.99 times 0.06 gives you that 6% sales tax that he pays in addition to the original price of the laptop. And so that's why we're going to get the same answer. So $2.99 times 1.06 is $316.94. I believe this method is a lot easier. Now let's move on to the next problem. Sally is currently paying $250 per month for car insurance. When she starts going to college, she will receive a 20% good student discount on her policy. What will be her new monthly insurance premium? So in this case, we're dealing with a % discount. So let's use the same formula. So the new price is equal to the original price multiplied by 1 plus or minus R. So the original price, her insurance premiums, is $250 per month. Now she's going to receive a discount. So should we use positive R or negative R? We're going to use negative R because the premiums will decrease after the discount is applied. So it's going to be 1 minus. Now what is 20% as a decimal? 20% is 20 divided by 100, which is basically 0.20 or 0.2. One minus 0.20 is 0.80. So she's going to be paying 80% of her original premium, which was $250 per month. 250 times 0.8, that's 200. So this is going to be her new monthly premium after the 20% discount has been applied. That's the answer. Number 3, Karen pays a total of $69.55 for a shirt with 7% sales tax included. What is the original price of the shirt? Now in this case, it's going to be very helpful to use that formula. Without the formula, it's going to be difficult to work backwards. So this is when the formula makes life a lot easier. So we have the new price, which is the total price after the tax has been added, and that's $69.55. We're trying to calculate the original price, so we're going to call it X. And we're dealing with sales tax, so that's going to increase the original price. So we're going to use positive R. 7% is 7 divided by 100, which is 0.07. So we have 69.55 is equal to 1.07x. So we need to divide both sides by 1.07. So let's cancel these two numbers. 69.55 divided by 1.07 gives us $65. So this is the original price of the shirt. So that's it for this problem. Number 4. Gerald buys a car worth $25,000. The car depreciates by 15% during the first year, and then by 10% during the second year. What is the value of Gerald's car after owning it for 2 years? Now, we can't combine 15% and 10% and say that his car is going to decrease by 25% over 2 years. It doesn't work that way. We need to do this one step at a time. So first, we need to decrease the car value by 15%. So this would be the same as solving a percent discount problem. So we could use the formula, the new value is equal to the original value times 1 plus or minus R. So the original value is 25,000. Since this is basically a percent decrease, we're going to use the negative sign. 15 divided by 100 is 0.15. So this is going to be 25,000 times 0.85. So if we're decreasing 25,000 by 15%, we're basically calculating 85% of 25,000 because 100% represents the whole 25,000. So 85% of 25,000, or 25,000 times 0.85, that's 21,250. So that's going to be the value of the car after the first year. Now let's see what it's going to be after the second year. So we could use the same formula. The original price is now 21,250. And during the second year, the value of the car is going to decrease by 10%, which means that it's going to be 90% of its value. So we're going to do 1 minus 0.10. 0.10 is 10%, or 10 divided by 100. So it's going to be 21,250, and 1 minus 0.10 is 0.9. So as you can see, we need to calculate 90% of 21,250. And so this is going to be 19,125. So this is the current value of the car after 2 years. Now, here's what we can't do. We should not add these two values and say that it decreases by 25%. If we did that, notice what answer we would get. Let's start with the original 25,000 number that we had. And let's say R is 25%, or 0.25. So basically, we have to calculate 75% of 25,000. And this will give us a different answer, 18,750. As you can see, it's not the same as this one. So just keep that in mind. Number 117. In 2008, the average rent price in a certain city for a one-bedroom apartment was $950. By 2018, the average rent price increased to $1,425. What is the percent increase in the rent price over the 10-year period? There's a formula in which we can calculate the percent change. Here it is. The percent change is equal to the new price minus the original price divided by the original price times 100%. So the new price is $14.25. The original price is $9.50, and we're going to divide it by $9.50 again. So $14.25 minus $9.50. Let me retype that again. That's going to be $475. Now let's divide $475 by $9.50. So that's 0.5, and then let's multiply that by 100%. So the rent increased by 50% over this 10-year period. Real estate tends to go up in value, but answer choice C is the correct answer. 118. The price of a stock changed from $70 to $48 in a 1-year period. What is the percent change of this stock over the 1-year period? So we're going to use the same formula. The percent change is going to be equal to the new value, which the new value is $48, minus the original value of $70, divided by the original value, times 100%. So 48 minus 70, that's negative $22. So now let's divide negative 22 by 70, and then let's multiply that by 100%. So you should get negative 31.4%. And of course, this is a rounded answer. So answer choice A is correct. So the negative sign tells us that the stock decreased in value. If we had a positive sign, it would indicate a percent increase where the stock would increase in value. But a negative sign indicates a percent decrease. Number 119. There are 35,000 cats on a certain island in 2000. Each year, the population of cats increases by 3%. At this rate, what will be the approximate population of cats by the year 2024? Well, let's find out. So let's write a formula. Let's say the population with respect to time is represented by the function p of t. Now, this is going to equal the initial amount times basically 1 plus or minus r raised to the t, where t is in years. The initial amount of cats, P0, is 35,000. R is 3%. Now notice that it increases by 3%, so we're going to use the positive sign. Thus, this is going to be 1 plus r. 3%, if you divide that by 100, is equal to 0.03 as a decimal. So, thus we have the formula for the population of the cats. It's 35,000 times 1.03 raised to the t. Now, t is 0 corresponding to the year 2000. So by the year 2024, t should be equal to 24. So let's go ahead and plug this in. So we're calculating P of 24, which is 35,000 times 1.03 raised to the 24th power. And so you should get 71,147.79. So rounding that to the nearest whole number, that's 71,148 approximately, which means answer choice D is the answer. Number 120. In the year 2000, there were 50,000 tigers on a certain continent. The population of tigers decreases by 4.5% every 5 years. At this rate, estimate the number of tigers that will be on the continent by the year 2100. So let's start with this formula again. So P of t is equal to P initial times 1 plus or minus R raised to the t. Now this formula is going to be different because t is basically the number of years. However, notice that the population decreases by 4.5% every 5 years. So in order for t to be the number of years, we need to divide it by n, where n is the number of times the population is compounded by a decrease of 4.5%. So in this example, r is going to be negative 4.5%. Or you could think of r as being positive 4.5%, but we're going to use the negative sign. Now the second thing is n is 5, because it's going to change by r every 5 years. Now the initial population, P0, that's going to be 50,000. So the formula is going to be 50,000 times 1 minus, now 4.5%. If we divide that by 100, that's 0.045. And then we're going to raise it to the t divided by 5. So we have P of t is equal to 50,000, 1 minus 0.045, that's going to be 0.955. And that's raised to the t over 5. Now, what is t in this example? In the year 2000, t is 0, but by the year 2100, t is going to be 100. So the population decreases by 4.5% every 5 years. So in a 100-year period, it's going to decrease by this amount 20 times. As you can see, 100 divided by 5 is 20. So this is going to be 50,000 times 0.955 raised to the 20th power. And so the population by 2100 is going to be 19,908 tigers, rounded to the nearest whole number. So that's how we can answer this particular type of question. Answer choice E is the answer. Number 121. The number of bacteria in a sample triples every 20 minutes. If there were 200 counts of bacteria initially, how many counts of bacteria will there be in 2 hours? Well, let's find out. So the population of bacteria is going to equal the initial amount. In this case, I'm going to say, let's use the letter x raised to the t over n. The initial amount is 200. X would be the number of times, let's say if it doubles or triples or quadruples. Because it triples, x is 3. T is going to be the time in minutes. Notice that it triples every 20 minutes. So n is going to be 20 or 20 minutes. So because n is in minutes, t has to be in minutes. Now, we want to find out how much bacteria there's going to be in 2 hours. So we need to convert that to minutes. There are 60 minutes in 1 hour. So this is going to be 2 times 60. So that's 120 minutes. So that's t. So let's calculate the population of bacteria 120 minutes later. So it's going to be 200 times 3 raised to the 120 divided by 20. 120 divided by 20 is 6. So in a 2-hour period, the number of bacteria is going to triple 6 times because it triples every 20 minutes. So 200 times 3 raised to the 6th power. This is going to be 145,800. So that is the population of the bacteria that's going to be present 2 hours later. So answer choice C is the right answer.